Hi, ITS 224, Linux, Chapter 6, Part 2. And in this part, we are once again working with shells, with developing scripts, with using variables within those scripts and assigning variables values. So in this case, we're going to create some variables called name and list. Now, name equals Becky. I'm going to try that. We should just be able to echo $name and then be able to view what name equals. Now notice we have Becky space J space Zubro. So whenever we have any variables that are going to have spaces in them, we need to go ahead and make sure we add some double quotes. And then we can view that with echo $name as well. Let's look at that. Okay. Back to there. Okay, there we go. And to there. That's what I want. So name equals Becky. Echo $name. Okay, that's good. That makes sense. So now we want to define name with Becky space J space Zubro. Okay. Now we also want to do the same thing, echo $name. Okay, that looks good. Now let's compare. If I go and pull the equals, or not the equals, but the quotes off of this, I get an error because Linux is seeing this long string that should look like one piece within quotes. Okay, so once again, we'll come back in here, and because it's a long string with spaces, we'll put the quotes back in, the double quotes back in, and there we go. Now also what we're taking a look at here is assigning list, the ls command, list command, to a variable called list. And we should be able to echo that out with this. Now, and what I'll do here is just for demonstration, for illustration, I'll put ls within the double quotes. And we'll see how the single backward quotes versus the double quotes actually work. So what we'll do is list equals, now backward single quotes below the tilde, ls, and now if I echo $list, that's actually what's in my files. Those are all my files. Now they aren't formatted out in any particular way, they're just kind of crammed all up with each other, but that's what that ls command does. Now if we go back in, and remember I had wanted to go ahead and change these to double quotes, what should happen? Well, it should make it look actually like a name itself, so it shouldn't. Well, we'll see. So if I echo $list, it just shows me, where am I at? It just shows me what I renamed the variable to. Instead of the command, when you set up these commands, you have to use the single backward apostrophe. When you're setting up variable names, put them in double quotes. Okay, now we have these math operators here too. So, and we've done this just a little bit. So if we let x equals 5, let y equals x plus 4, as long as I'm in the same session, x will be substituted into place, and I should be able to echo what y equals out. So let x equals, what was it, 5 I think? Let y equals x plus 4. Did I get that right? Yes, I got that right. Okay, so echo $y. And the answer is 9. Okay. Now, and these are the whole set of examples of the shell's arithmetic and relational operators. The next piece of this, and I've talked about this with some of you before, is this no clobber environment variable. So what we're doing is setting, and we're using -o. -o sets a particular shell mode so that when used by the no clobber as the argument, it prevents files from being overwritten by the use of the greater than or the redirector operator. Okay, so in order to set your shell environment to where files can't be overwritten, we need to go and type in set dash O clobber, no clobber. Okay, now what should happen is this. Let's look at the directory, and we see zoo1, zoo2. And actually, let me take something else, so if I mess up, I'm not messing up on some of my files I want to keep. Test zoo3. So we want to, let's see, cat v1. Okay, we'll take a look at v1. That's taking a look at v1, redirecting it into test zoo3. Did I get that? I must not have gotten that right. Okay. Cat. Oh, okay. Cat. Do I have anything in v1? Okay. v1. Redirect it into test. Was it dash underscore? Okay, there, that's, and it probably said that up above here, didn't it? It said cannot overwrite existing file. And so that's what that no clobber does. Is it makes it so that you can't overwrite an existing file. Okay, so that was perfectly slow, but that demonstrated that point. Now, your login script file is your .bashrc file. That contains all of your login information. Now, it has a dot in front of it. Notice that. That means as you just list the files or show a directory of files so that it's hidden. So what I'm going to do is vi.bashrc. I'll go ahead and enter and edit bashrc. Okay, this is the entire file. Okay, a lot of comments in there. Those pound signs are comments. But what you can do is enter some environment variables within this particular bashrc file, so that every time you log in, it will restart reset those environment variables for the particular session. So what this is talking about, though, is creating an alias. So you do this and you set this up in the bashrc file. So when you log in, that I'll be able to just type in rm for any time that I want to remove a file, but be prompted when I remove it. Okay, so let's put this in here. Insert. And that was alias rm, and I can call it whatever I want, equals, okay, if we notice the back are the single apostrophes, single apostrophe I think should work, and that should be rm dash I, and let's make those double apostrophes. I think either will work, but let's do that because of the example that I have here. Okay, escape, right. Okay, then I'm going to go ahead and exit. Okay, so I've completely logged off the system. I'll go back into the system here again, run it, Linux, and then at the top part of the screen, and it'll take a second for it to complete its login here. When it does, what should happen is I should be able to go ahead and delete, or try to delete a file, but it should come up and prompt me and say, it should prompt me and ask if I want to, let's see, if I want to delete it. So that'll take a second just to go ahead and get there. And then as we look at this, and well, let's see if I need to change that. And it always takes a while to log on there, doesn't it? Come on, come on. The next piece that we'll take a look at, though, to introduce that is a trap command. There we go. Let me go back to the previous screen. So let's see if that alias actually worked. So I should be able to show a directory. Again, I have, where am I at? Zoo or test zoo3. Let me remove test underscore zoo3. Okay, so it comes up and asks, remove regular file zoo3, yes or no. So I didn't have to reset the variable, that rm variable for rm space dash I. Whenever I log in, it'll go ahead and be there and prompt me so I'm sure I want to delete the particular file. Okay. Now let's go back to this point, this trap command. Now what happens to the trap command? You typically run it out of a shell like a script. Okay. What happens in this case, and you'll see this on page problem project 620-335. So this is it's returning a when a specified signal is received from the OS, a specific command is executed. Okay, that's what's happening. In this case, that the RM removes the files, and the files you're removing are just temporary files. We can see this from your home directory /tmp. Those are just temporary files, and it's cleaning up all the temporary files. In the green, it redirects output of removing files to a null device. So it just goes up to a null device. You don't actually see it happening. Exits out of the shell after removing the file. And then 0 is the code generated when a shell script is exited. So it's just going to go ahead, remove the files, set it up so you don't see it happening. It'll quit running the program when it gets to this point, and then it jumps out of the shell. Okay. Now with trap, if you type in trap-l, that lists signal numbers and designations. So there's a whole bunch of them. There's about 25, 30, 35 signal numbers and designations. This is just an example of a few. Now I wanted to go ahead and use this trap within a program. So what's happening in this program or this script is that it's going to go ahead and run, and it's going to disable trap echo 2 and 2 meaning a control C. So I'm going to go ahead, and anytime it sees a control C, it's going to disable it. Basically, is what's happening. And then it's going to go ahead and never exit. So this is what the output should look like. Type in, and because it's interpreted, sh space test underscore trap. That's what I call this file. And then it just runs with the dots, and then I hit the control C, and it just continues to run. Control Z hasn't been trapped. Therefore, it'll stop with Control Z. So let's go back to this was called test trap. So cat test underscore trap, and then we see test trap here. Okay, so trap echo 2 and 2 is the Control C. So it is going to ignore the Control C. sh test trap. So you can see it's just running. I'm going to press Control C, and excuse me, and it doesn't stop. Control C, so that that signal has been turned off. Control Z will go ahead and exit me out of the program because I didn't turn that signal off. Now shell scripting is, and basically what we're doing here with this, in short, we're using tput position to position stuff on the screen. So tput cup 00, that is the top, the left hand, the 0 left hand column, the 0 upper row. Okay, so that's what tput cup 00 means. It's simply positioning stuff on the screen. The next slide, figure out where I am, is kind of an overview or a summary of these particular commands. Export that we did in part 1, alias, case, if then else's, which we'll look at a little bit more on the next part. and then set, like with no clobber, sh for running a particular interpreted script. Tput cup moves the screen cursor around, clearing and so on and so forth. Works with the screen resolution. And part 3 will start at Unix Linux shell scripts. Okay, thank you.